Welcome back to the real number system. Today, we're going to talk about section 3.5, and we're going to look at dividing whole numbers. Through this section, we'll look at models for division, we'll look at algorithms for division, we'll look at mental computations with division, and also estimation. So let's get started. Let's think about what division is. Division is the inverse operation of multiplication. So when we say that A divided by B equals C, what that means is C, our quotient, times B, our divisor, equals A, what we call our dividend. So again, A is our dividend, B is our divisor, and C is the quotient. Then we have a couple of ways that we can write division. We can write division with the fraction symbol, or we can write it with what some people call the doghouse. Let's look at our models for division. Our first model for division is our partition model. So what happens here is we take the dividend and we divide it into a certain number of subsets. Now that number of subsets is going to be our divisor. So let's suppose that we have 18 cookies and we want to divide this among 3 of our friends, Bob, Dean, and Charlie. And I want to use the partition model to illustrate this division. I'm going to start by drawing 3 different subsets, a group for Bob, a group for Dean, and a group for Charlie. Now, I want to divide the 18 cookies among these 3 different groups. So I'm going to start by counting 1, 2, and 3. So notice I gave 1 cookie to Bob, 1 to Dean, and 1 to Charlie. I'm going to keep counting. So we have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now notice here, Bob had 6 cookies, Dean has 6 cookies, and Charlie has 6 cookies. And so my answer here is 6. In other words, 18 divided by 3 is 6. Let's look at another example. Juan is organizing his closet. He has 27 pieces of clothing, and he's putting these pieces of clothing into 9 different groups. And we want to know how many pieces of clothing are in each group. Let's use the partition model again to illustrate our division. So we have 9 groups. I'm going to draw 9 circles to represent my 9 different groups. And I start by putting a piece of clothing in each group. Now I'm going to use a dot to represent my clothing. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now I'm going to continue counting and putting a dot in each circle. So as I put the dots in each circle, 10, 11, 12, 13, 14, 15, 16, 17, 18 dots now. Then continue. So we have 19, 20, 21, 22, 23, 24, 25, 26, 27. So I've put all 27 pieces of clothing into a group. Now notice each group has 3 pieces of clothing, and so our answer here is 3. In other words, 27 divided by 9 is 3. Let's look at our next model. It's called the missing factor model, and it focuses on the relationship between division and multiplication. So remember, the opposite of division is multiplication. A divided by B equals C, provided that B times C equals A. So in our example, we have 20 riders that we're going to place on 4 rows. And I want to know how many riders are going to be on each row. We use the missing factor model here to illustrate our division. So I'm wondering, 4 times what makes 20? Well, when we think back to our multiplication facts, we remember that 4 times 5 equals 20. And so our answer here is 5. In our next example, Solomon has 10 cups of flour. He wants to make cookies, and 1 batch of cookies requires 2 cups. And what we want to know is how many batches of cookies can he make? Notice again, our directions ask us to use the missing factor model to illustrate our division. So I think to myself, 2 times what equals 10? Well, when I think about those multiplication facts, 2 times 5 equals 10. And so my answer here is 5. Our next model for division is called our repeated subtraction model. So what we do here is we repeatedly subtract the divisor from the dividend until we have only our remainder left. Now our remainder has to be smaller than our divisor. So let's look at an example. Mrs. McCormick has 28 students and she puts her students in groups of 4. How many groups is she going to have? Use the repeated subtraction model here to illustrate our division. So I start with 28 and I'm going to subtract 4. Subtract 4 again gives us 20. Minus 4 is 16. And I want to keep subtracting 4 until I can no longer subtract 4. 16 minus 4 is 12. 12 minus 4 is 8. 8 minus 4 is 4. And 4 minus 4 is 0. Now, I said a minute ago that I want to keep subtracting 4 until I can no longer subtract 4, and I need to add something to that statement. I want to keep subtracting 4 until I have a number between 0 and 3 left, because remember, my remainder can't be bigger than my divisor here, which is 4. So count how many times you subtracted 4. Well, notice that we subtracted 4 7 different times. So my answer here is 7. In other words, 28 divided by 4 is 7. Let's look at another example. John has 30 pieces of candy. He puts his candy into groups of 5. How many groups of candy will he have? Again, our directions ask us to use the repeated subtraction model to illustrate our division. So 30 minus 5 is 25. Minus 5 is 20, minus 5 is 15. Remember, I'm going to keep subtracting 5 here until I have a remainder between 0 and 4, inclusive. My remainder can't be bigger than 5. 15 minus 5 is 10, and keep subtracting 5 until here, notice we get a remainder of 0. I want to know how many times I subtracted 5, so I'm going to count how many times I subtracted 5. And I subtracted 5 6 times. So 6 is my answer. In other words, 30 divided by 5 is 6. Now, just like subtraction, division is not closed in the whole numbers. For instance, if we have 18 cookies and 4 friends that we're going to share them with, we would have, each friend would get 4 cookies, and we're going to have 2 cookies left. This leftover part is called our remainder, and our remainder cannot be bigger than our divisor. This leads us to what we call our division algorithm. So notice here the division algorithm says that A, our dividend, equals B, our divisor, times Q, our quotient, plus R, the remainder. And notice the statement at the end. Our remainder is between 0 and B. So our remainder is 0 or greater, and it can't be any bigger than B, our divisor. We say that A is divisible by B if we have a remainder of 0 when we divide. That also, another way to say this is that B is a divisor of A, or that B divides A. By the division algorithm, A is divisible by B if A equals B times Q. Now notice the remainder is 0, so we don't have the R there. So 63 is divisible by 9 because 9 times 7 is 63. Using the same reasoning, 63 is divisible by 7 because 7 times 9 is 63. Let's use the division algorithm to help us solve a problem. Here we have 123 is divided by some number, and we have the remainder as 13. We're trying to figure out what our possible divisors are. So I start with the division algorithm. A equals BQ plus R. A is 123. It's called our dividend. B and Q are our divisors. We don't know what those divisors are, so I'm going to leave the B and Q. And then R represents our remainder, which is 13. A couple of slides ago, when we first talked about the division algorithm and that R, remember we said that R is between 0 and B. In other words, it can't be any bigger than B. So that tells me that B has to be bigger than the remainder. So here, B has to be bigger than 13. Your divisor will always be bigger than the remainder, or the remainder will always be smaller than the divisor, depending on how you look at it. Subtract 13 from both sides gives us 110 on the left side. And so now what I'm thinking about is the factors of 110. So let's start listing those factors of 110. Well, 1 and 110 are factors of 110. And one thing I've learned is that if I start thinking in order and counting 1, 2, 3, that's going to help me get all of those divisors a little bit easier and make sure I don't skip any. So after 1 comes 2. Well, 2 goes into 110 55 times. After 2 is 3. 3 does not divide into 110. Then we have 4. 4 does not divide 110. 5 does divide 110, and 5 goes into 110 22 times. 6 is not a divisor of 110. 7 does not divide 110. 8 and 9 do not divide 110. And then we have 10 goes into 110 11 times. Now, after 10 is 11, and notice 11 is already in my list, and so I found my factors of 110. So let's go back to thinking about our divisors and our remainder. Our divisor always has to be bigger than that remainder. So that tells me that my possible divisors will be 110, 55, and 22 because they have to be bigger than that remainder of 13. And so my answer here, my possible divisors, are 22, 55, and 110. Let's look at another one. So let's suppose we have 108. It's divided by a number. We're trying to find that number. And our remainder is 3. And I want to know what are my possible divisors. I start with my division algorithm. A equals BQ plus R. So 108 is my A. I'm looking for the divisors, so B and Q I'm going to bring down. And my remainder here is 3. Remember, our divisor has to be bigger than the remainder. And so B has to be greater than 3. Let's solve for BQ. Subtract the 3 from both sides gives us 105. So I want to think about that 105 and the factors of 105. Well, 1 and 105. Again, I'm going to count in order to help me get all those factors of 105. So I started with 1. After 1 comes 2. 2 does not divide 105. 3 divides 105. It goes into 105 35 times. 4 does not divide 105. 5 is a factor of 105. Goes into 105 21 times. 6 is not a factor. 7 goes into 105 15 times. 8, 9, 10, 11, 12, 13, 14 are not factors. And then the next number is 15, which is in my list. Now, my possible divisors have to be greater than 3. So all of these are my possible divisors. These are the numbers greater than 3. And so my answer here, my possible divisors, are 5, 7, 15, 21, 35, and 105. Now, let's talk about division with 0. I'm going to start with B. But to review, remember our relationship between multiplication and division. So if we have A divided by B equals C, and you'll notice I wrote the IFF. This is a mathematics abbreviation for F and only F. So here, A divided by B equals C, if and only if B times C equals A. Now remember, our answer, that C, has to be a unique number. Well, 0 divided by 3 in part B is 0, because 0 times 3 equals 0. You're familiar with that one. But let's look at A. 3 divided by 0, so notice that 0 is second here. This one is undefined. Now this is undefined because there's no number that I can multiply times 0 and get that 3 that I started with. Then part C, we have 0 divided by 0. Well, at first glance, you could say, well, 0 divided by 0 is 1 because 1 times 0 equals 0. Or 0 divided by 0 is 2 because 2 times 0 equals 0. But remember, our definition says unique. So this one is undefined. It's undefined because there is not a unique. Unique means only one. So there's not a unique number that we can multiply times 0 to get 0. So to summarize, n divided by 0 is undefined, 0 divided by n is 0, and 0 divided by 0 is undefined. So if you ever divide by 0, as in the first and the third, notice that your answer is undefined. What happens when we divide by 1? Well, remember, n times 1 equals n. We have our relationship between multiplication and division. So here, n divided by 1 is n because n times 1 equals the n that we started with. Multiplication and division are inverse operations, just like addition and subtraction are. In our next video, we'll continue with division algorithms.